Hello everyone, today we're going over our system design course today, and today we are focusing on the concept of resource descriptive framework. Now, what is resource descriptive framework, or RDF? At its core, RDF is a standard model for data integration on the web. So it is a standard model for web integration. But why is this important? Well, RDF has been based on making statements about resources in the form of subject, predicate, object expressions. So, based on subject, predicate, object expressions. And these are called triples. So let's imagine a scenario where we have information scattered across different databases altogether. And each piece of information can be seen as a small fact or triple. So this is a piece of information. And it's considered a structure that includes a subject, a predicate, and an object. For example, with the color blue, can be broken down into the subject, such as the sky. Let's put our sky right over here. A predicate is, and then the object, blue. In RDF, these triples are used to make assertions about resources, anything that one can think of that could be identified using a unified unique identifier called a URI. Unique URI. And this system allows data to be mixed, exposed, and shared across different applications. RDF triples can be written in various syntaxes, such as Turtle or RDF/XML. Can be written in RDF/XML. Let me just make this clearer for you folks. And Turtle as well. And Turtle is a more human readable format, making it the preferred choice for many. For those who need to work with machine-friendly code, RDF/XML is an option, and there's tools such as Apache Gina. Which can convert the data between these following formats, making RDF flexible in general. The real magic of RDF overall comes from its foundation in the concepts of URI. This means that anything defined in an RDF triple can be a web resource, providing a global way to identify anything we talk about. And this is crucial in linking data across the vast expansion of the internet. If we were to have a following search of queries as well, it overall allows us to utilize RDF to facilitate web data, what we might call the semantic web, and where data can easily be integrated regardless of where it originates from. And now let's head over to our concept example. Let me just clean this up for you folks. Yeah, it's Gina, J-E-N. there we go. And feel free to take a screenshot before we move over to our concept example. And now let's look at a concept example. So suppose we have a website that provides information about different countries and cities. In one database, we have a city for Paris, namely, and it's tagged with the country France. So we have an RDF file for cities and locations. So in this case, in this example, we have Paris as a city. Then we have France as a country. And then in another case, we may have Paris also integrated with sightseeing. And overall, the RDF allows us to be able to merge these data sets seamlessly, given the fact that they're focusing on two different subjects that we have. Really just, even though that they are related with Paris, the city, we also have France as a country and then sightseeing as well. Now, if we want to create a comprehensive guide for tourists about Paris altogether, we would need to gather this information about the country and the attractions it offers. Instead of manually searching each database, we instead are able to integrate this information altogether to create a richer experience and without that much extra legroom. It's the beauty that lies in the RDF's ability to use URIs. So this is all leveraged using URIs, which give every single piece of information as a unique identifier that can be referenced across the web. And it doesn't matter if one database uses a symbol for France in particular, like FR, to refer to France, and another person to use French Republic, as long as they are tied within the same URI. As long as they are associated within the same URI, they are able to be in the same RDF altogether. And this is the foundation that brings us data exchange, is mostly in the power of the URI. There we go. And now let's head over to our practice problem. And now let's go over our first practice problem. So in our first practice problem, let's consider the scenario of developing a smart library catalog system. This library wants to offer a service where users can search for books not only by titles or authors, but also by related subjects, published years, or even language. So you have a smart library that wants to figure out how to search for not just titles, but also include related subjects, published years, and languages. To achieve this level of detail of data integration, RDF model would be deployed, and with our following tasks, let's just go over our RDF file that we have. So let's go over our first one to be able to help understand. So let's call upon the example of the Great Gatsby, for instance. The author would typically have a URL, or URI, sorry. The author would have another URI, such as F. Scott Fitzgerald. Similarly, we create URIs for each year, language, and category. So we have the year, language, and then category as well. So all of these are separate URIs. but they are integrated in the RDF format. All the URIs are integrated, and so what we are doing is that once we have already created triples, namely such as creating the title, creator, date, language, and subject, which will already have our subject, predicate, and object, we will be able to integrate all of our information into RDF. So in RDF, to avoid writing out full URIs every time, we use a namespace DC, namely, just to go over, which is a common naming prefix standing for doubling core, a set of vocabulary terms used to describe web resources. And overall, by following these steps, we're able to create our RDF file for the library, and this is just a concept overview for a specific example for an RDF file. And now let's go over a second practice problem. So let's focus on the scenario for actually dealing with personalized music recommendations. So in this practice problem, we're considering a music streaming service. So we're doing a music streaming. That wants to provide personalized recommendations for its users to tailor recommendations. The service needs to understand the relationships between musical genres, artists, albums, and individual songs. So we already need to know what our subject, predicate, and objects are. So the subject would be the listeners. The predicates would be the relationships with the songs. And the objects would actually be the songs, the actual songs. So the relationships for the song could be taste, preference, or it could be other varieties depending on what aspect of music they are looking for. Maybe an individual artist, or maybe a specific genre in particular. The predicates can go on for a countless amount of selections. So overall, we are focusing on developing a RDF model that includes a new album called Jazz Vibes with the artist Ella Fitzgerald, which features songs from jazz and was released in 2021. And this allows the same steps as practice problem 1 to build our RDF triples, because every aspect of data is going to have subject, predicates, and objects. And so if we were to go further in depth inside of our script that we have over here, we notice in particular that we have our album, then we have the artist as well, and the genre, and also the album year as well. So in this case, over what we have is that we are creating our RDF file based on one, aside from the triples of our following information, based on the album, artist, and genre, and also release year as well. Because we can have multiple predicates inside of our triple as well, as long as we're able to differentiate between what the subject, predicate, and object are. So the subject will be the album, the predicate will be the relationship of the album, and the objects could be artist, genre, and year. Again, the objects can go on for many, many situations. We just have a main subject that we're already focusing on in this triple, and every single component of the RDF file is going to be comprised of URIs, which differentiate them. So we have URIs to differentiate, and also we have namespace such as DC right here, to simplify our triples to ensure we don't have to write out the full URIs every time. And so yes, this was RDF, or Resource Descriptive Framework for System Design. Thank you again for taking time to watch this. If you found this video helpful, be sure and feel free to like and subscribe. And if you have any other questions, feel free to put it in the comments section. And as always, take care. Cheers. Bye-bye.